So today we will studying about dual nature of radiation and matter. So today topic is dual nature of radiation and matter. So next part, today part is 3 of dual nature. So let's see the next question, that is 18. If the kinetic energy of particle, if kinetic energy of the particle is increased to 16 times, right, its previous value. So kinetic energy is increased 16 times that of the previous. The percentage change in the de Broglie wavelength. So you have to find, suppose initial de Broglie wavelength is lambda naught. So what will be the lambda final when it becomes 16 times, right? So you have to find the value of this one. It is asked in 2014. So how will you calculate? So by using the formula of de Broglie wavelengths. So we know the de Broglie wavelength equation. De Broglie wavelength is given by lambda equal to h upon p, right? When we write in kinetic energy form, as we know, kinetic energy formula is 1 upon 2 mv square. So to write in the form of p, I multiply numerator and denominator by m. Then it will become m into v square upon 2. So this is the initial kinetic energy. Here I have multiplied m and divided by m. So numerator will become now m square v square upon, and denominator will be 2m. And as we know, momentum is nothing but mass into velocity. So when it is m into m square into v square, then it becomes p square, momentum square. So numerator will be p square upon 2m equal to kinetic energy, right? So p will be under root of 2m ke. So instead of p, I will write under root of 2m ke. K is nothing but kinetic energy, right? Understood up to this point?
Yeah.
Okay. So this will be the initial lambda, right? That is lambda naught for the case 1. And if you are changing the kinetic energy up to 16 times, right? So this will be the initial kinetic energy. So next will be lambda d, suppose I am taking. So it will be h upon under root of 2m. And this is 16 times of initial kinetic energy. So it will be 16 ke naught. Understood? Now divide equation 1 and 2. So this h and this h will get cancelled, right? And m2 and m will also get cancelled. K naught and K naught also get cancelled. So you got the relation lambda naught upon lambda d is equal to. So this will come in the numerator, right? This will be in the numerator, right? We have got like this. 1 upon 1 divided by 1 upon under root of 16. So this will be coming in the numerator. Then under root of 16 will be 4. Lambda naught upon lambda d. So you have to find lambda d. So lambda d equal to lambda naught upon 4 times. Understood this one? I have taken lambda here and this 4 in numerator. So this will be the relation between lambda d and lambda naught. So right up to this point asked in 2014. One additional question asked in the previous one is, you have to find the percentage change. So how will you do? It will be the initial minus final, right? Divided by initial into percentage. Then you have to multiply with 100. So take the LCM. It will be 4. So numerator will be 4 lambda minus of lambda divided by lambda. Then it will become 3 lambda upon 4 lambda, right? So this lambda and lambda will get cancelled into 100. 4 divide 100 in by 25. So 3 into 25 will be equal to how much? 75. So changes in the percentage will be how much? 75% in lambda. So this is the additional question asked in that. Now we'll solve the next one, 19. A piece of iron is heated in a flame. So iron metal is there. It is being heated. Then its temperature will be increased, right? If first become dull red, initially it becomes dull red. Then become reddish yellow. Then become reddish yellow. And finally turn to white. Finally turn into white. The correct explanation for the above observation is using. So this is asked in 2013. So your next. So as we know from the above option, Wein's displacement law, black body radiation curve for temperature weak wavelength. So lambda and temperature is given by Wein's displacement law. Lambda m equal to b upon t. So this equation is called Wein's displacement law. It's called Wein's displacement law. Wein's displacement law. So please remember this one. So when we increase the temperature, lambda will be decreases. Understood? So this is the relation between lambda and temperature given by Wein's displacement. So this law is called, this question is that which law is related with lambda and wavelength. So Wein's displacement. Next question is 20. For photoelectric emission from certain metal, cutoff frequency is given. Suppose this is your metal, right? So its function is called work function, right? Its frequency is given, that is cutoff frequency is called. It is mu given. If the radiation of frequency 2 mu impinges on the metal plate, 2 mu frequency is impinging on this metal or it is following on this metal. The maximum possible velocity. So electron is coming out from here. So you have to find the maximum kinetic energy or maximum velocity through which electron is coming out, right? So you have to find the basically velocity of electron, right? So yesterday I have told you Einstein equation. So write for that. It is nothing but initial kinetic energy is sum of phi plus final kinetic energy, right? This equation is called Einstein photo equation. Yeah, photo equation. Everything is in the form of energy. E is your initial energy. This is metal energy. This is your final kinetic energy through which electron is coming out. So write in the form of energy. So here energy formula we know, right? E equal to h mu. And this equation is called Planck's equation. Planck's equation. H is Planck constant. Mu is frequency. So EI is written as h2 mu. Initial frequency is given, right? This year initial frequency is 2 mu. It is given in the question. And phi. So phi energy we know in the form of energy. So it will be h mu given for the metal. Cutoff frequency is given now. This one. This is mu. Plus kinetic energy value we know, right? That is 1 upon 2 mv square. Now calculate it. So you have to find the basically velocity, right? So this value you have to find. So take on the left this part. So it will be h2 mu minus h mu. Subtract, then you will get h mu. Understood? Equal to 1 upon 2 mv square. Then it will be 2h mu divided by m equal to v under root of. This will be the velocity formula, right? Through which electron will be coming out. So write this proof. This question is asked in 2013. Write it down first. Next question is 21. Two radiation of photons energy is given, right? So energy of first one is 1 electron volt. For second photon energy is 2.5 electron volt. So this is the energy for photon. Energy of photon. Successfully illuminate a photosensitive metal surface of work function. So these are the two energy falling on this metal surface whose work function is given. It means phi means initial value of energy is given, that is 0.5 electron volt. These are the two same metals. The ratio of the maximum speed of the electron. So you have to find V1 for this and for this also. Because energy is different, following on this. Here energy value is 2.5 electron volt. Understood? So coming out will be 1 upon 2 m V1 square, and another electron that is coming out is 1 upon 2 m V2 square. Asked in 2012. So write the Einstein equation and solve it. Then you will directly get it, right? So there are two cases here. Solve one by one. So write for first one. It is initial kinetic energy is equal to phi plus final kinetic energy. This energy is given, that is 1 electron volt. Phi V value, it is given 0.5 electron volt plus kinetic energy formula is 1 upon 2 m v square. Right, subtract, then you will get 0.5 electron volt equal to 1 upon 2 m v 1 square. Understood? And for second one, write the for second case also. This is your case 2. So initial kinetic energy is equal to phi work function plus kinetic energy final. Initial kinetic energy that is given 0.2.5 electron volt equal to phi is given. Metal is same, so work function will be same. Kinetic energy is 1 upon 2 m v2 square. Subtract these two, so you will get 2 electron volt equal to 1 upon 2 m v2 square. Now divide 2 by 1 or 1 by 2. You will get the ratio. So this is equation 1, this is your equation 2. Divide 1 by 2 or 2 by 1. Then you will getting here 0.5 electron volt equal to 1 upon 2 m v1 square. So this half will be get cancelled with m also. Electron volt and electron volt also get cancelled. Ratio will be v2 upon v1 is equal to under root of 20 upon 5. So this will be get cancelled, under root of 4 equal to 2. So answer is v2 by v1 ratio is 2. Right? So write the explanation. Next question is 22, asked in 2012. If the momentum of electron is changed by P, momentum is changed by P, P for momentum. Then the de Broglie wavelength associated with is changed by 0.5%. Initial lambda is lambda, so it is changed to 0.5% of lambda. Lambda d is changed to 0.5% of initial lambda. The initial momentum of electron will be, right? So this is the final momentum. Initial momentum you have to find it. Initial momentum. So how you will be solving? Write the equation, de Broglie equation. So as we know, de Broglie equation is given by lambda equal to h upon p, right? So how lambda and this is related? Lambda into p equal to h, right? This is the first one, initial value. So when we are writing or changing the relation, suppose I am taking lambda d, then it will be lambda p equal to h, because product of lambda and p is constant. So lambda into p equal to delta lambda into delta p. What will be the explanation then? Take this p in denominator and this lambda on this side. Then what will be the equation? Lambda by lambda wavelength by lambda d. Lambda means changing. Then it equal to lambda p upon p. This will be the equation. Are you getting?
Yes, sir.
Okay. So next part is given that de Broglie wavelength associated with change by 0.5%. Right. So equation we have got is lambda by delta lambda equal to lambda p upon p. Right. So this initial p have to find. So p will be equal to lambda d into lambda p upon lambda. So this change is given 0.5 lambda, 0.5% of lambda into lambda p upon lambda. So this lambda and lambda will get cancelled. We have to find in percentage form. So it will be how much? It will be 5 into percentage means 100 and divided by removing this point, then you will get 10 here and it will be P. So this and this will get cancelled. So it will be P is equal to 50 of P. Understood? So right up to this point. Now look at the next question, that is 23, asked in 2012. If the momentum, it is done, right? 23 is 200 watt sodium street lamp emits yellow light of wavelength. So this is the street light, right? So its energy is given, that is E equal to 200 watt, made up of sodium. And it is emitting of lambda, that is 0.6 micrometer. Assuming it to be 25% efficient. 25% efficient in converting the electrical energy into light. It is converting electrical energy, right? Consuming electrical energy and converting into light. So transfer of energy is happening. A number of photon of yellow light. So you have to find the number of photons. So n is nothing but number of photons. Number of photon of yellow light it emits per second. So number of photon n by t you have to find it. Number of photon per second. So we know the formula, right? Power is nothing but it is energy upon time. Energy formula we know that is Sc by lambda, and T is in the denominator, and it is producing number of photons. So multiply it with N. So this is the power formula in terms of HCN by lambda into T, right? Instead of E, I have put E equal to H mu. And mu is the frequency related with C by lambda. So this is the basic formula. You have to just remember it. Now put the value. You have to find N by T. This relation you have to find it. This one. So take it on the left side. So N by T will become how much? P into lambda divided by HC. Put the value. Right. Energy value we know how much it is. That is 200 watt. Lambda we know 0.6 micro means 10 raised to minus 6 divided by H Planck constant, that is 6.626 10 raised to minus 34 joule second, into speed of light we know 3 into 10 raised to 8 meter per second. So calculate it, then you will get as 1.5 into 10 raised to 20 photon upon time. Next question is 24. Right from here. ये मिट गया क्या? अरे ये तो मिट गया भाई, अंडू कैसे करते हैं? हाँ आ गया आ गया। ये लिख लो।
डन सर।
नेक्स्ट पेज राइट कर लो, फिर लॉग आउट करके लॉग इन करना, 1 ही मिनट बच रहे हैं। ये लिख लो पूरा। हो गया लिख के?
हाँ सर।
ओके, लॉग आउट कर लो, फिर से लॉग इन कर लो।